Just send you a link, Brenda. It'd be great if you'd watch it because it might help you understand how we see gravity. Because obviously
You
you've got
don't
your
believe in
view on it.
gravity. You don't believe in gravity.
For me personally, gravity's nonsense. It doesn't exist. I agree. But
Uh,
the current physics states that it does exist, but they have
yeah.
trouble defining it. I think we can
No, we
agree that
don't have
that's
trouble defining it. We don't have trouble defining it.
well. I'm going to send you a video that shows that they do have trouble defining it because if you ask four physicists what gravity is, you would expect to get 3.5 answers that were consistent, right? You wouldn't expect to get
No,
four different answers.
the physics textbooks all say the same thing.
They don't. That's the point. They don't.
No, they actually do. They do.
Okay, so I'm
The
going to send you.
textbooks, the textbooks say the same thing, but accounts that are in popular magazines, even popular science magazines, can differ, right? Because it's for a popular audience, and people are using words in a way, in a poetic way, to express ideas that are difficult to explain to people. But the physics textbooks all say the same thing about gravity, every one of them.
Brenda, I've sent you the link, and I've put the link
Yeah,
with
I'll
it so that
watch
you
it
remember.
sometime. I'll watch it sometime, but
But,
not right away.
no, I'm not asking you to watch it right away. But if you want to understand why we think that the way we do, if you watch it, it itemizes why, and then consider it when we ask you what gravity is, or fight the
But you
flat Earth.
don't believe in gravity.
Yeah, but you guys have got to give us the official story, right? You guys
Yeah.
can't wander
Well,
off.
the official story is in the textbooks.
Right, but this is what this guy's demonstrating that four physicists, current physicists, don't give the same definition for what gravity is.
Uh, that might be. I don't know.
And that's what
They
I'm saying.
might
That's the
give
point I'm making.
different. They might give different explanations that amount to the same thing, and
Oh yeah, because we know that
flat
one and three
earthers.
makes. We know that
Yeah,
1 and 3 makes 4, 2 and 2 makes 4, and 9
yeah,
minus
yeah.
whatever makes 4. But my point is this: if everyone's describing it in different ways, how the fuck is anybody meant to learn what it is, even on
Well,
your side? How
I
are we
can
meant
tell
to?
you what
How,
it is. I can tell you what it is. Mass distorts space time around it, and in such a way that it causes other uh, um, objects with mass, right, to move.
it doesn't. That's the effect.
It does.
It doesn't. That's the effect. But anyway, the point that I'm
This
making,
is
Brenda, is
you get hung up on this problem all the time, Nate. Anthony, you get
Nathan.
well. I
Ooh,
forget names.
Freudian slip there.
You get it's not Freudian. It's just I'm not in the loop all the time. So you get confused and you think that a cause can't be an effect, but it can be.
I don't.
A
I don't.
cause can create an effect, and then that effect can be a cause to another effect, which can be a cause to another effect. It's
Yeah,
a
but then
causal chain. That's
okay,
how it
but
works.
we only have one cause and one effect as defined by current science on the topic of gravity.
No,
The cause is
that's not
the
true.
cause, Brenda. The cause is the uneven distribution of mass, and the effect is the effect of the curvature of space time. Now that effect
Right.
isn't causing something.
Yes, it does.
It doesn't. We perceive that
Yeah,
effect, not cause. We perceive the
it
effect.
gives no, what it actually does is it creates a vector that other objects with mass will then be accelerated.
So when you say it creates a vector, what is the it that creates the vector?
Um, the mass creates a gravitational field which distorts space time, and that distortion of space time will in turn create a vector to any object with mass that is in that field. And so that vector will cause that object to accelerate.
No, it doesn't cause the acceleration. It disturbs the right. What I'll say to you, Brenda, you have when you put your mind to it, you are probably one of the best people to transpose from Newtonian into Einsteinian and give some explanation because most people on your
I
side can't even
understand.
do that. What?
Well, I do not know the math and the physics and the chemistry as well as people, other people. Many of them are engineers. They know the math very well. But yes, I do think I have an ability to put things in a way that it helps to explain things. And I can do that in other areas too. So I don't always have expertise, but I have, I guess, an ability to translate things. So I'll take that as a compliment. Thank you.
Brenda, can I ask you a
So
question? You talk about physics, huh? How can space-time be physics? What is
Well,
physical
hang on. I was
about
just
space-time?
hang on. Don't answer that just yet. I was just going to get to that. It was meant as a compliment, Brenda. It wasn't meant as a dig, and you can take it as a
yeah,
compliment. It
I
was
took
meant
it.
that way because most
Yes,
people on
thank
your
you.
side
I
can't
did.
even do that. Now, here's the thing, though. Scorpio just said, how is space-time physics? That's what I was just about to get to. Because whatever space-time is, right, we know that it's a mathematical concept that he derived and represented mathematically. We also know that it hasn't got any experimental application because you can't do any science with it. You can observe, but you can't experiment with it because it's maths-based. So
No,
on that understanding of the inability to do any experiment, that renders space-time to be a construct mathematically that we reify every time we talk about it, but it doesn't actually exist.
no, space time is a physical aspect of the world, of the universe.
It's mathematical, it's
So
not physical.
no, it's described by mathematics, but that's you confused. That's you doing the reification error.
Well, no, it's described mathematically, but it is conceptual.
Yeah,
It's not physical.
yeah. Well, I can describe lots of things with mathematics, but I
Yeah,
shouldn't confuse the map with the territory, right?
correct. Well, that's the map with the territory
Right.
that you're citing, but you're
Well,
right.
the
Yeah,
mathematics
but,
is the map.
yeah, but we should. You're right. We shouldn't conflate mathematics with the real world, right? Because mathematical
Right.
descriptions can be useful, but they don't prove cause. Agreed?
Well, they describe, what
If-
we know so far. They're
Yeah,
descriptive. They're
yeah.
descriptive.
So we can
Yeah.
see a mathematical
And we shouldn't
correlative. We see a
right,
mathematical
but
correlative model for the clockwork sky that we observe, but that doesn't
yeah,
mean that we understand what's causing it
we can use that description to do things.
to
So
make predictions. Yeah,
if I have a random McNally atlas of the highway of the road system in my country, to get from one city to another city, but I shouldn't confuse the map with the actual city. But I can refer to the map as a way of describing where I am and what I need to do to get to where I want to go.
yeah, but we need to be careful that when we're describing mathematical correlations, that we don't conflate them with science or technology, because maths is abstract. It's not immersive. It's not comprehensive. It's abstract, right?
Well, math is the language of science.
No, the language of science is cause and effect,
Yeah.
not mathematics.
Uh, No, mathematics is the language in which scientific ideas are expressed in.
Well, it's a
It's used
language, but it
everywhere.
isn't the language. Like I said, it's abstract. By
Eh,
definition, it's abstract.
eh, people who don't speak English can read quite a lot of like physics papers, and they don't, and there won't be very much that they'll miss because almost all of it's going to be in terms of mathematics and formulas.
Yeah, but Fight the
And
Flat
so you can
Earth.
understand just
Fight the Flat Earth has a conversation
yes,
with George Musa, and somehow at the end of it, he thinks that George Musa agreed with him, despite expressly stating
he
twice that
did,
he didn't agree with him. But because he said it in a polite and professional way,
but he
he
did
totally
agree with them.
misinterpreted the sign.
No, he agreed with them that you can talk about it in a way that talks about forces, as long as you understand that these aren't real forces, that there's an underlying reason for that, for what we see.
That wasn't
What
what
it
he said.
really
What he
is,
said was, what Brenda, his words were, gravity's not really a force, but you can think of it as a force. Now, if you want to
yeah.
think of it as a force, that's your prerogative. The problem arises when you tell people that it is a force when you know that it's not.
Well, highway Interstate 80 isn't actually a blue line, but I can think of it as a blue line on the map, so I can get from city A to city B, and it will get me there because there's a correspondence So there's a correspondence between the math and the science and the reality. They correspond with each other. There's a correspondence between the marks on my map and the roads and the places and the cities and the towns that are in reality. They correspond with each other.
Sorry, I was on mute. Sure, but when it uses the language of mathematics, you have to understand that it's abstract. It might be descriptive, but it's not causative. And when we're
Well,
talking
of
in
course it's
science,
abstract. I agree. I don't disagree with you about that. It is abstract.
okay, so
That's why it's so powerful. That's why math is powerful, right? Because um, I don't have to count every single grain in a bushel of wheat. I can just count it as one bushel of wheat, and then I can add those and subtract them, right? And I can get 10,000 bushels of wheat, and I can subtract 1,000 bushels, 1,000 bushels. I can know what I have.
I'm going to step back because I've just got breakfast. So give me 10 minutes. Somebody else can take over, Bev or whatever.
Yeah, Brenda, you want a debate? Is that what you wanted,
Well,
or did you just want to come for a chat?
I felt, I felt. So I hear you. I sometimes go around on uh, um, YouTube channels and listen to debate things, and there were some points felt I wanted to address, and I feel a little bit shut out because I was from the former Discord channel that you were in before.
Yeah, that wasn't us. That wasn't.
Yeah, but I got banned from there, and
Yeah,
this
I
seems to
don't know
happen
who
to
it
me a
was
lot.
that banned you.
I get
You
yeah,
weren't banned
I
from
get
here
banned
though.
a lot. Yeah, so I did have something specific in mind, which is how many dimensions surface of a sphere have?
Sorry, Brenda, you're breaking up there. Do you want to
How
just
many dimensions does how many dimensions have?
Brenda? Do you want to just nip out and come back in again? It's cutting out badly. I can't hear what you're saying. Hello?
That is weird. Something going on.
Yeah, that's still pretty bad. That in and out.
Yeah, she was sounding shit. I couldn't make out anything she was saying.
Hear me?
I heard a bit then. What's it look like? Your connection's like? It sounds pretty bad here.
Anthony didn't seem to have any
Yeah.
trouble.
No, that sounds
No,
bad.
you're right. But for some reason, you do sound shocking at the minute. Do you want to just ask your question again and see if it comes through?
So my question was, that my system is downloading an update, for instance. My question, because it is Tuesday. Oh, it isn't.
It's
Um,
Thursday.
could be. The question was, how many dimensions does the surface of a sphere have, Bev?
How many do I think? Yeah, 3.
Yeah, there is an objective
Really?
reality here, Brenda. It's not an opinion, is it?
That's incorrect. That's wrong.
What do you mean it's incorrect?
It's wrong.
What?
It's objectively, mathematically wrong.
Can we just get a definition of 2 dimensions for you?
Right. Do you know what a dimension is?
Yes.
So how many dimensions does a line have?
Geometrically. Geometrically, yeah, Brenda.
You're gonna play. You're gonna play games. Is that what
No,
you're gonna do?
I'm asking
Nicole?
you to qualify a
How
line
many
geometrically or a
dimensions?
line on a piece of paper.
How many dimensions does
Please,
the line
please
have?
qualify, Brenda. A
There's no
line
qualification.
geometrically
There's,
or a
there's no
line on a
qualification.
piece of paper.
There's no difference.
Yeah, there is.
There's no qualifications. A mathematical line has how many dimensions?
Within
All right.
Euclid, in the definitions of Euclid, in Euclidean geometry, it is one-dimensional, described as
Well-
length without breadth.
Yeah, but that length
Right.
could be on the y-axis as well. It would have to be horizontal to be one dimension. If it was on the
There's no
y-axis
such
as
thing
well,
as
and it was
one
on an angle.
dimension, Tony. Doesn't
No, I know.
exist.
I know, but
it doesn't matter. It doesn't matter what axis it's on. It has one dimension.
it does matter what axis is on because that's where we get three dimensions from: X, Y, and Z.
No.
No.
It is just one
No.
of the dimensions, Tony. That's it. So that's length, right, Brenda?
Right. And the reason is because we can specify any point on a line with one number, one dimension, right?
No, a point is 0 dimensions, Brenda.
Points have zero
Is
dimensions.
that
but we
without
can,
any parts?
points have zero dimension, correct? But we can specify a point on a line with one number, right?
I don't know. Like a line.
What do you think it takes?
What do you mean you can specify a point on a line with one number? You can specify a point on a line with a letter as well, can't you? If you mark it with a letter.
The letter would also
Yeah, you just
the
have to
letter
put
would
that
also
aside.
be a dimension, wouldn't it?
The
Right,
letter
'cause
would
I
be an
could specify-
identifier for either the point
Yeah.
or the line.
Yes, a
That's
dimension.
all it would be, Brenda. That's all.
Dimension.
Yeah.
You're the
You
the-
do
you're the
realise in
person that thinks
geometry
you're a
there's
geometry
no
genius.
numbers involved, right?
So we can assign numbers to a line,
Who?
and we can
Euclid.
specify.
Euclid
we can,
didn't define
we
any
can-
numbers, did he?
But we can do that.
Well,
no, this
yeah, but
is like
but
third-
in geometry,
this
if
is
that's
like
what we're
third
talking
grade,
about with
this is-
lines,
Yeah, this is third grade geometry, right? So this
yeah.
is.
Well, you
this is
don't
for
need
children.
numbers then, Brenda. You're trying to
Yeah,
talk about
no,
dimensions, right?
That's not true. We can specify. We can assign numbers to a line, and use those. Those are the dimensions, right? So we can specify a point on a line using numbers or letters, any symbols, right?
Yeah, you can call it Bob if you want. You can do anything you want.
Yeah, that's what children do.
Yeah.
We teach them geometry in elementary
You
school.
teach them
and it's fairly
geometry?
simple. Well, we do.
We?
Humans, we people.
But not you specifically.
Yeah. So
So, Brenda,
can
but
also-
not
we
you
can also-
specifically. Can
we
I get a
can also
clarifier
use-
on that, please? Because I do actually
Yeah,
teach my
it's
son
irrelevant.
geometry. So when you say we,
yeah, that's child abuse. That's child abuse.
what, teaching my child geometry?
Yeah, because you're not teaching them geometry. You clearly don't understand geometry.
Pardon?
You don't understand geometry.
Brenda, what was the answer to your question? How many dimensions does a sphere surface exist in? What was the answer?
Well, Bev said 3.
Yeah, what's your answer?
Well, the correct answer is 2, of course.
So, is the reason why you say it's only 2, is that reason because we see things from our perspective pretty much flat?
No, that's not
So,
why.
what's your justification for 2 dimensions for a sphere then?
Because it takes only 2 numbers to specify any arbitrary point on the surface of a sphere.
Oh, right. So, from a
That's what makes
perspective of a grid line system on a sphere, you can get away with X and Y only if the grid, if it's wrapped around
Yeah,
it.
this is the formal mathematical definition of any two-dimensional surface is that it takes two numbers or letters, they can be algebraic or numerical, to specify any point on the two-dimensional surface,
So what you do
albeit
there is you get the grid
or a
system.
sphere or
So correct me if
well,
I'm
yeah,
wrong, Brenda.
that's called geometry.
Yeah, so correct me if I'm wrong. You get a grid system, you overlay the grid system, and then wrap it round it so that there's no gaps. And then you put your grid system, and in any direction, you can get any position on it based on that, right?
Well, you have a coordinate system, and it can be any kind of coordinate system you want because, of course, planes and lines and surfaces are continuous.
So what kind of geometry would you describe that, where you get a grid system with curved lines and wrap it around a model? What kind of geometry is that?
So we're talking about two-dimensional surfaces.
We're not. We're talking about three-dimensional surfaces that you're redefining into two-dimensional surfaces by creating a construct that wraps around it that you then put a grid on with bendy lines on. There's a name for that. What is that name?
No, you've misunderstood all of that.
No, I haven't.
I'm not creating a grid system, right? We're using coordinates to describe a two-dimensional surface.
Well, here's the thing, Brenda.
Why has Bev gone silent?
I'm here.
Because I stamped on him. All right, I'll give way if you want. Go on, you carry on, Bev.
So do you understand?
Like,
this is elementary geometry.
Yeah. Have a look in the live stream text for us, will you?
I have no idea where you're live streaming.
Well, in live stream text, you're in the open live stream. Above it is live stream text, so that's the text for the live stream that we're in, right?
Makes sense. I'm in no voice.
Yeah. That's only for the people that aren't brave enough to come and talk to us, Brenda. That's where they like to stay.
Right.
So have a look in the live stream text, right? Can you see that?
I see it.
Right.
I see it. I see it. It says
a
solid. I can read.
It says
solid.
book 11 definitions. And that's how it starts. The book 11 book 11
I can read.
of Euclid's
I can
Elements.
I can read, and I can read faster than you. A solid is that which has length, breadth, and thickness. That which bounds a solid is a superficies, whatever that is. That's an antiquated word.
That's a
Does
surface.
the surface, right? Does the surface have thickness?
The surface is what bounds
Does the surface have
the
thickness?
three-dimensional object.
Does
And in the
surface,
case of a sphere,
does the surface of a sphere
three-dimensional,
have
isn't it?
thickness?
I think it is
No,
anyway.
does the surface
that's
of a
just personal
does the
opinion
surface
and
of a
things.
sphere have thickness?
Pardon?
Does it have thickness, Bev?
It has
Does
three
the surface
dimensions
of a
because
sphere-
it curves in every
doesn't.
one of those dimensions.
No, it doesn't.
Yeah, it
No,
does.
the surface
It's
of
not
a sphere
two-dimensional
has
plane, is it?
It's a two-dimensional surface. It's
I
not
know,
a plane,
but
but
Brenda,
it's
this is
still a
because
two-dimensional surface.
you want to live on a two-dimensional surface, don't you?
No, that's not because I want my math to be correct. And the surface of a sphere has no thickness, just like a plane has no thickness, right? Planes don't have thickness.
It's just got length and breadth. Then there's no third
correct.
dimension to it, so it's a flat.
Right.
It's like a plane.
No, it doesn't have to be
sphere
flat.
is a plane surface, is it?
No.
Well, that's what a plane is: length and breadth, right? Two dimensions.
Right, and the surface of a sphere
with no third dimension.
The surface of a sphere has only two dimensions. Right?
How can it? It's a three-dimensional object, Brenda.
It's not. It's two-dimensional.
No, a sphere is three-dimensional.
The sphere is three-dimensional.
It's in
but the
book
surface,
11 of Euclidean.
Yes, but you don't understand.
Elements.
You don't understand.
I don't understand.
And this is fifth grade geometry, and you don't understand it.
And I don't understand.
The sphere has three dimensions, but the surface of the sphere has two dimensions.
And
you don't understand it. No, you don't understand.
When you have a ball, Brenda, right, and you roll it, the ball rolls
Right.
on the
We're
surface
not
of the
talking about the
sphere.
ball.
Yeah, well,
We're talking about
that's
the
what's
surface
touching.
of the ball.
And when you put it on
We're
a
talking about the
flat
surface of the
table,
ball, Bev.
right? The
Not the ball.
table is
Not
flat,
the ball, Bev.
two-dimensional, and the ball rolls on it.
Right. How many coordinates does it take to
It
describe
doesn't take.
any
There's no
point
coordinates,
on
no
the
numbers
surface
in geometry, Brenda.
Yes, there is. Yes, there
Where?
is. It's called analytic geometry.
But yeah, that's
So,
not in this
yeah,
geometry that we're
yeah,
dealing with here.
yes, I know, because you can't understand elementary school geometry. So
No,
it only takes two
this is the
coordinates.
basic geometry, Brenda.
Yeah, and you don't understand it.
And I don't understand that a surface of a
correct. You
sphere
don't.
is
You
three-dimensional.
do not. Yes, it's two-dimensional because it only takes two coefficients, two dimensions, to describe any random point on the surface of a sphere. The surface of a saddle, which is, or a pseudosphere, also can be described using only 2 points. I mean, two coefficients, two dimensions, right? So you have planar geometry, the surface, a planar surface described by 2 dimensions.
Yeah, that's book one.
Non-Euclidean geometry, the surface of a sphere described by 2 dimensions.
Sorry.
Hyperspherical.
Which one? Non-Euclidean.
Geometry. Yes.
So not
hyperspherical.
Euclidean geometry then.
That's correct.
Right. So can you give me the definition of a sphere
elliptical,
in that geometry for us, please?
in elliptical
Let's
geometry.
have the definitions and the axioms and all of that for that geometry, please.
Well, one of the axioms is
Brenda, I can show you the Euclidean, right? You said that's
Right.
basic, right? You then said non-Euclidean, right? Show
Yes.
me the axioms and definitions for that geometry that you're talking that's not
yes,
Euclidean.
I can.
You
Yes,
can't?
in non-Euclidean, yes, I can.
Well, go and get them for us,
Non-Euclidean
please. Stop talking about
No,
it,
I can-
Brenda. Stop.
No, I
Stop.
can. I know this.
No, I don't
stuff.
want to.
It
I
isn't
don't want to
hard.
hear from you.
Yes,
I want to look
you do.
at
No, all I have to do is
the
describe it to you.
axioms, please.
No, you can look this up yourself.
No,
because
no,
this is
you can
elementary
show it
stuff.
me because I'm showing you Euclidean geometry, right? You're
I'm
saying not
describing-
that geometry. I want to know
describing
which
non-Euclidean
not
geometry,
that
which
geometry you're talking about, please.
Yeah, I understand. In non-Euclidean geometry, the definition of a parallel line of the fifth postulate is changed
Yeah?
from 1 to infinite.
What do you mean?
Well,
The
Euclid's
definition of a parallel
I thought
line
you would have-
goes from
I thought
1
you
to
would have-
infinite. What's that mean?
I thought you would have Euclid's postulates memorized by now, right?
I do, yeah.
Euclid's fifth postulate says
No, that's the
that for-
the 12th axiom, the one in my book, anyway.
Euclid's fifth postulate is that for any point, for any line and a point not on the line,
No.
there's one and only one line which is coincident with that point, which does not intersect with the line. Right? In
if
elliptical
it's- it-
in
well,
elliptical geometry,
Brenda,
there's an infinite
If
number of
a
those
straight
lines.
line meets
And
two
in
straight
and in
lines
hyper,
so as
and
to
in-
make
and in
two
pseudospherical-
interior angles on the same side of it, taken together less than 2 right angles, these straight lines, being continually produced, shall at length meet on that side on which the angles which are less than 2 right angles.
so
That is the 12th axiom in my book.
right.
Okay.
Right. I'm just going by the fifth postulate as I learned it, which is that for any line
Right,
A
so
and a point B,
but
not
that's
on line A.
Euclid, right? You're
Yes,
you're
for any
saying
line
not
A-
Euclid.
Right, but I'm telling you what the fifth postulate
I
is.
know what the
and
fifth
how it's
postulate
different,
or what you
and
think.
I'm telling you how it's different. I'm telling you
how
how it's
is it different? Because that says
well, if you,
parallel
if you would
lines
actually
will
stop
not meet.
fucking talking,
What's the
maybe I
difference,
could
Brenda?
say. So the difference is that in Euclidean geometry, where it says there's only one line through the point, not on a line.
No, parallel lines do not
Right.
meet.
Yes, but I'm putting it more formally. Probably you don't understand that, right? That's the problem, is that you only understand things as a sacred
I can
text.
explain it to you, Brenda, if you want me to
Well,
explain how
no, I don't need it
the parallel
explained. I
postulate
don't need it
works.
explained.
Okay,
So
well,
if you
I'm just
just
thinking
allow
for
me to
anybody
talk,
else. If anybody else
so
is
if you would
going to be
allow me to
listening
talk
to this,
instead
they
of
might be able to learn something,
constantly
mightn't they?
interrupting me. No, so the fifth postulate says for any line A and point B not on line A, there's one and only one line which passes through point B and yet does not intersect with the line A. That's Euclid's fifth postulate.
That's not.
Yes, it is.
No, that's a modern
That makes,
reinterpretation of it, isn't it?
so it doesn't matter. It's
So
the same thing.
I can read you out the actual one if you want me to.
It doesn't
Again.
matter. It's not a sacred
It's
script.
not right. Okay. So
It's
what
not a
is
sacred
the
book.
not
This is not a holy book.
Euclidean geometry
So
statement?
in non-Euclidean in elliptical geometry, right, there would be an infinite number of lines passing through point B, which would intersect with line A. And in hyperbolic geometry, there would be no lines.
Is hyperbolic not non-Euclidean geometry as well? Is that just
Correct.
a name for a non-Euclidean geometry?
You don't know what hyperbolic geometry is?
Yeah, of course I do.
Yeah, so it's
So how do you differentiate hyperbolic from non-Euclidean?
Well, hyperbolic
I'm sorry,
has
Bev.
negative curvature.
Bev, I insist that
you-
Brenda asks.
and
Bev,
elliptical
listen,
geometry has
make
positive
Brenda
curvature.
answer that last question. The last question you asked her was, is hyperbolic a type of non-Euclidean geometry? Make her answer that with a
Yes, it
definitive.
is. Yes, it is.
Right. Thank you.
Yes. In hyperbolic geometry, the
Okay,
space
so
has
when you say
negative curvature everywhere.
non-Euclidean, do you include hyperbolic, or do you just add that on afterwards for extra thing? So when you say non-Euclidean, you mean hyperbolic and other geometries as well, do you?
Well, you would get that from the context. Normal people can understand context.
Okay, so is hyperbolic geometry the non-Euclidean geometry that you're going to be using?
No.
No. Okay.
We're talking about a sphere.
Which
as
is
you
the
recall,
non-Euclidean
as you
geometry
recall,
that you are going to be
it's
using, Brenda?
It's spherical. It's spherical geometry.
Okay, right. Okay.
Because we're talking.
Brilliant.
Because you
Well
asked
done.
about. Because you asked about the surface of a sphere. The surface of a sphere, right, can be described by only two dimensions. Therefore, it is two-dimensional.
Yeah, but you do have a problem, don't you? Because the framework
No,
of
I
that.
don't.
Yeah.
There's
The
no
framework
point,
of that
no point on
geometry
a
that you're
sphere.
dealing with there has
Excuse
to be
me,
built
there's-
around Euclidean spheres, right? That which
There's
are
no point.
three-dimensional.
There's no point on the surface of a sphere that cannot be described by using two dimensions.
Would that be like latitude and longitude type thing?
That would be one way. You could
So that
use.
they'd be
you could use other coordinate
two-dimensional
systems.
coordinates, right?
You could use other coordinate systems. You could use polar coordinates or other coordinates.
But
right?
they
But
would be classed as two-dimensional coordinates, would they?
Right, because the surface is two-dimensional.
Okay, yeah, brilliant. But can
Good.
we just go back
I
to
get
that
that
the fifth
that is
postulate that you said?
That's you
Can we go-
agreeing.
can we
That's
go-
you agreeing, right?
Can we go
You
back?
just agreed that the surface of a sphere is
No,
two-dimensional.
I just
correct?
admitted that longitude and latitude are two-dimensional coordinates,
So
and
could
you
you
said
give me-
the surface is two-dimensional, and I agreed with you. Yes.
Could you give me
Can
the
we
three
go
coordinate-
back? Can we go back
No,
to the
no,
postulate that you said?
No.
The fifth.
No.
You said
No,
it
we can't.
changed from Euclidean to non-Euclidean somehow.
No.
How's that?
You need to. If you say that the surface of a sphere is three-dimensional, right?
Yes, because the sphere.
Give me
it is
give me the
bounding.
three. Give me the three dimensions.
Length, breadth, and height.
The surface of
Oh,
a
sorry,
sphere
thickness.
doesn't
Length, breadth, and thickness.
have, right. The surface of a sphere has zero thickness.
Sorry? It has a
surface-
diameter, doesn't it?
No, the sphere has a diameter. The surface does not.
But from side to side. Of course it does.
No, it doesn't have thickness.
The surface goes like from one side of the sphere to the other.
No,
like,
it doesn't.
Of course it
No,
does.
it doesn't go. No, it doesn't. It simply covers the surface. It doesn't.
Which is three-dimensional.
Traverse.
Yeah.
It does not. It does not traverse
You're not
the
going to get
interior
me disagreeing with you.
of the sphere.
It is a sphere that is three-dimensional, and the surface
Yes,
covers it.
The sphere is three-dimensional. The surface is two-dimensional.
Seems a bit funny. This. Can we go back and do your postulate?
No, we
thing?
need to. This is what we're going on until you come to understand it.
No, Brenda, what you're trying to do is get me to change my mind, and I'm pretty
Yes,
rock
yes,
solid
I
that
am.
when I look at a ball, a sphere, the surface wraps around that sphere. So when
Yes.
I'm looking at a sphere, I'm looking at the surface. So therefore,
Yes.
when I look at it, I see a three-dimensional surface.
No, you don't. You see a
Yes, I do.
two-dimensional surface.
Don't tell me what I
wrapping
don't see,
around-
Brenda. I'm
You
the
see
one
a
that's looking.
Two-dimensional surface. Too bad.
You
Too bad.
think it's
You don't get to have-
two-dimensional, and
you don't get
that's
to have-
brilliant and all.
Fine.
But
Fine. Then give me the three. Then give me the three dimensions that
length,
describe the
breadth,
surface of a sphere.
thickness.
There's no thickness to the surface of a sphere. It's zero.
There's a diameter to a sphere, so
That's
would
the
be
diameter to the sphere, but that's not the surface, is it? That would be the interior, wouldn't it?
the interior. Yeah, well, that's the distance from one side to the other.
Right. That would be the
Yeah, in
inside of the
all-
sphere,
in-
not
in
the surface. In
all
other words,
directions,
not the
Brenda.
surface.
In
That would be
all
the surface.
directions. You're thinking of a flat somehow.
No, I'm not thinking.
Yeah,
of
you're
flat.
thinking
There's
of a plane.
No, I'm not.
Yeah.
No, I'm not.
You're getting
There
confused
is
with,
no-
with reality that you
there's
see
no
that is
flat-
on a plane. And you're then thinking, that has to wrap around a ball. So therefore, what
Yeah, that's
I
exactly
see
what it does.
is a plane, and that must wrap around a
No.
ball. Therefore,
The surface of a
two-dimension
sphere
of
isn't
a
planar.
surface of a
What
sphere
are you
must
talking
be
about?
two-dimensional, right?
The surface of a sphere is not planar. It's curved everywhere.
Yeah,
It has
exactly.
no
In
flat
three
surface on it.
dimensions. Doesn't curve in just two dimensions, does it? It curves in three.
It doesn't matter.
Bev,
It's
a sphere.
two-dimensional.
Bev,
Two-dimensional
it's-
object
it's-
in a three-dimensional space. Yeah.
Brenda, just give me a sec. It seems that where the issue is that in reality we've got a three-dimensional object. Mathematically, Brenda's found a way to describe it in using just two axes by bending a grid system around it, and then she can claim that it's only in two dimensions, but it's only in two dimensions within that grid system, that model that she's created. In the real world, it is three-dimensional, Brenda.
Yeah, she's
Math-
reverse
math is a-
engineered
math is a real
spherical
world.
geometry, or
We're
reverse
not talking
engineered
about we're not talking about
coordinate
the real
system.
world.
Yeah, we are talking about the real world.
No,
Everything we
no,
talk
we're
about is
not.
about the real world. Yeah, we
Talking
are,
about
Brenda.
math. We're talking about math. We're
No,
not
no,
talking
How-
we,
and how
we are
abstract.
talking about reality.
abstractions. Yeah, but math is not real. It's an abstraction.
You're
Exactly.
the one that's talking about math.
Exactly. Yes.
You're
Exactly.
making
We're
our
talking
point
about math.
perfectly, Brenda. Because you can abstractly
Yes.
describe something mathematically doesn't mean the
Yes.
reality is the same. And a sphere is a brilliant example of it. Well done.
Right. Right. A rubber ball is not a perfect sphere.
And
Yeah, I'm not talking about a rubber ball. We're talking about a mathematical object called
no.
a sphere.
no,
Which has a two-dimensional
We're talking
surface.
about an actual sphere in reality.
No. We're
Yeah,
not.
yeah, we
no,
are.
We're not.
We are.
No, we're not.
I know you
No,
don't
we're
like
talking
the
about-
you don't like reality
we're-
very much. It's
No,
imaginary, right?
I love reality, and
Okay.
and this is the description. These are abstractions. These are abstract concepts which you have extreme difficulty with, elementary school concepts. So a sphere is a three-dimensional object which has a two-dimensional surface.
Only if you use a bendy line geometry coordinate system. In
Yes,
reality, it's still
in-
Brenda. It's still three-dimensional in real world, and that's what we're talking about.
in elliptical geometry, lines are called are called great circles. Great circles are lines.
What's the fifth
So in that
postulate,
case,
Brenda?
Brenda,
What's the fifth
hang
postulate,
on.
please, Brenda?
I've just realised. If we apply Brenda's grid coordinate system and describe it as two-dimensional, that means you can't distinguish between a sphere and a circle, because a circle's got 2 dimensions on the x and the y axis, but your sphere's also got 2 dimensions. So how would you distinguish mathematically between the two models?
They are topologically equivalent.
So then you can't distinguish between a sphere and a circle.
Well, you could. Yeah. Well, I don't know. I don't think so.
There you go.
It has a two-dimensional surface. Well, one way is that on the surface of a sphere, you can have 3 right angles, and they will on a triangle that will add up to greater than 180. And that's not true on a planar surface. On a planar surface,
the point I
on a
made though
planar
is
surface,
but Brenda,
planar
do you want?
surface, you can have on a planar surface the interior angles of a triangle will add up to 180 degrees.
Sure.
On a spherical on a non-Euclidean spherical surface, it's greater than 180 degrees, and on a hyperbolic surface, it's less.
So Brenda, let's just push your concept of your abstract maths
So
out
that's how
stage
you
further.
that's how you would distinct. That's how you would tell.
Okay.
If you're on the surface of a sphere, and that is in fact one way that we can
Right,
show
give
that
us
the
a
Earth is in
second
fact
with this
round.
one, Tony.
Is by
this
showing that there are
Brenda,
that you can have
yeah,
3 angles
with triangles, but
on the
we
surface
bring
of the
it
Earth
back to
that
reality.
add up to. I'm talking about reality.
Right. Well,
On
let
the
me
surface of the
let me
Earth,
jump
you
in.
have the interior triangle angles of a triangle add up to greater than 180 degrees.
Yeah, you say that, right? Brilliant.
That's how it works on a spherical
Brenda,
surface.
surveyors, like they work in reality, right? Now, when they measure and they do triangulations for measurements, do they have more than 180 degrees when they measure the triangles on the land?
Yeah, I don't know anything about surveying.
Well, they're triangles, right? So you just said if you want to work out the angle, the surface that you're on, you measure the interior angles of a triangle, Gauss, right? So when the surveyors are out in reality with their theodolites measuring angles and triangles and distances and stuff, do they measure more than 180 degrees in their triangles?
I don't know. You could have Jesse Kozlowski come in and talk. I don't know.
Oh, right. But you just claimed that there was a way of you knowing what sort of a shape you live on. But you don't know whether that would happen or not.
Oh, it does happen, and people have measured it.
So they have measured more than 180 degrees in triangles?
Yes.
Right. Who?
Three 90-degree angles. 3 90-degree angles.
They've measured 3 90-degree angles in a triangle, have they?
Yes.
Measured in, like, surveyors?
Yes. Well, not surveying. It would be too large for surveying, right? So you would start, for instance, at the equator.
Right, but then, no, but Brenda, we're talking about reality, right? You've just said you are talking about reality. Stick to reality. Surveyors, do they measure triangles with greater than 180 degrees? Please.
I have no idea.
No.
I have no idea.
Okay. So
I have no idea.
There's no point for you to bring that point up then, is there?
This isn't the point of surveying.
What?
This is the point where you can.
But you've just said you don't know, so why do you bring it up?
I don't know about surveying. I do know
Well,
about
why do you bring it up then?
Because this isn't surveying.
What isn't surveying? The reality of geometry.
What you're not letting me talk about is what's not surveying, which you know, and you're not letting me talk about it because you're afraid. So you start from the equator, right? And
Brenda.
You go to make a 90-degree
you're
angle
on
from the
a
equator,
modeler, aren't you?
North Pole. Just a minute.
Is this on two-dimensional coordinates?
You know, if you're just going to continue to interrupt me, I'm going to leave. Well, that's what you're here for, right?
That's what I'm here for.
Right. Is to get one over people that you don't like.
Sorry?
Yeah, that's you're here to get satisfaction about getting it over on people that you think have wronged you in some way.
I don't, where's this coming from,
That's why
Brenda?
you
I'm
interrupt.
more interested
That's
in
why you
this now. It's
interrupt.
much better.
No, that's why you
You,
interrupt
do
so
you
much. That's
feel
what
that
people
you've
do.
wronged me, or do you feel that
No,
I think
I
you
think
might
yeah,
have wronged me
I
some
think
way?
that this is your way of getting back at people for some unknown reason.
What, by
By by
explaining
being
about
by
reality and geometry and
by being a Poe on the internet because you're a Poe,
Poe?
right? You're a Poe.
What's a pro, Brenda?
You don't know what a Poe is?
I'm just you know what I'm me. You know me. I'm just here doing this.
No, you're a Poe.
What's that, Brenda? Please.
Somebody who pretends to be something they're not.
What am I pretending to be?
A flat earther.
That you think I'm not. I've always said,
You're not a
Brenda,
flat earther.
I'm not. No, because there's
Yeah,
topography, mountains and valleys negate
yeah, but
flatness.
nobody thinks that that's no flat earther thinks that because we have valleys and mountains that the earth isn't flat. Nobody thinks that.
You think the surface of a sphere is
No,
two-dimensional. That's pretty much the same, isn't it?
no, it's not the same.
Yeah,
But
it
there are
is. That's the way I
there
see
are
it. The mountains and valleys, right?
let me give you a hint.
They're
Let me give you a hint.
three-dimensional. They're not
Real
flat.
real. Let me give you a hint. Real flat earthers are not distracted by the fact that we have mountains and valleys. They think that the earth is still flat, even though there are hills and valleys.
Okay.
They know that.
What
But
about
you don't
real
know
globe
that.
earthers?
You
Do
don't
they
know
think
that
that the
because you're not
surface of a
very
sphere is
smart.
two-dimensional?
You don't know that because you're not very smart at pretending to be a flat earther.
All right, I'm not pretending to be me correctly enough.
No, you're pretending to be a flat earther, but you're not smart enough to pull it off.
Brilliant. Can we go back to reality then?
Sure. If you
yeah.
take a right angle from the equator, go north to the North Pole, take
Yeah.
another right angle, and go back down to the equator again, and then back to your original point, you have in a triangle with three 90-degree angles that add up to greater than 180 degrees. And that's how you can know that we live on a globe.
No, that's how you know you've just done geometry on a ball.
Yeah,
Yeah.
yeah.
Yeah, but
And you can
do
do
they
that
do
in
they
real
do
life.
that in reality,
Yes,
right?
yes, yes.
We'll check with Jesse, right? That he measures triangles with greater than 180 degrees, because if he does, then he would be validating what you say. But if he doesn't, and like I suspect, triangles only have 180 degrees in them.
Well, triangles
Otherwise,
on
they're
the
not
surface
really triangles as far as I'm concerned.
No, that's you trying to think.
Triangles
that it's
have
a sacred text.
3 straight sides and 180 degree internal angles. That's what I know about triangles.
Not in non-Euclidean geometry. They don't.
Oh, okay.
Yeah, on the surface of a
Do
sphere.
you want to go back to the fifth postulate in non-Euclidean geometry, just for
No, I
everyone
want you to
that's,
tell me. I want you
so you
to
don't
tell
know
me.
then? Nah, okay.
I want you to tell.
You don't
I want
really
you
know
to
the
tell me.
ones.
I want you to tell me the three dimensions of the surface of a sphere.
Length, breadth, and thickness, as defined. Book
The surface
11.
The book
of
doesn't say
Euclidean
anything about a
geometry.
surface. The
Pardon?
book doesn't say that the surface has. The book doesn't say the surface has thickness.
That which bounds a solid is a superficie.
Surface is a surface.
Yeah.
Right. It doesn't say that that surface has thickness.
Yeah, but there is a dimensionality to it.
No, it doesn't say that.
What? It doesn't say
Definition
that a
2.
surface of a sphere has dimensionality to it in
Definition
3
2.
dimensions.
Yeah, definition 2 says nothing about the surface having thickness.
It says what which bounds a solid. I mean, I don't know what you're talking
That
about
which
thickness
bounds-
for.
Yes, I know,
the
because you
surface
said it
is
has thickness.
three-dimensional. That's
It doesn't
just
say
a
that.
personal opinion, Brenda. I mean,
It doesn't say that, though. It says, one, the solid is that which has length, breadth, and thickness. That's the solid. But the surface is that which bounds the solid.
yeah. I just
And it
think when
doesn't
I
say
look
that
at a sphere, I'm looking at the surface of that sphere. Now, when I
Right.
look
And
at
the
it,
surface is
it
two-dimensional.
looks three-dimensional. So therefore, when asked the question, is the surface of a sphere 2D or 3D, I would say 3D. It's just a personal
What are
thing.
the three?
And there's no
Fine,
need
then
for
give me the
anybody to
three
get
coordinates.
upset or, get all
Give me the
heated
coordinates.
just because somebody
Give me
says,
the coordinates.
pardon?
Give me the coordinates. Give me the coordinates.
Coordinates of the surface of a sphere.
Yeah.
It's a sphere, isn't it?
No,
it
give me
rolls
the
about.
coordinates.
It rolls about.
I know it. No, the sphere does. Give me
Yeah.
the coordinates.
Do you want? Should we fix it upon an axis?
Give me the
And
coordinates.
define a tilt to it. Give it a vertical and a horizontal. Should we?
No, we're talking about the surface,
Yeah,
not
if for
the
a
sphere.
sphere, you would have to, in order for it to give coordinates, you would need to fix it about an axis that it was steady on, wouldn't it? Stop it from moving.
No.
Of course you
This
would.
is a
You'd need to
mathematical
say,
object.
here's your start point.
Mathematical objects don't roll about and they don't need fixing. We can assign
A 2D
coordinate system anywhere
object
we
don't
want.
roll about. I'll give you that. 2D objects
Just give
definitely
me the
don't roll
coordinates.
about.
Give me the coordinates. So you got nothing, right?
Yep. I got
Yeah, you got nothing.
nothing.
You got
yeah,
nothing.
Obviously.
That's right.
Yeah.
That's right.
If you want to give
try
us
harder.
the
When you
axioms
wanna
for your
When
geometry.
you want to pretend to be a flat earther, try a little bit harder. Think it through a little bit more.
Brenda, can you see the mountains and valleys?
Said no flat earther anywhere.
Right.
Real
well,
flat
That's
earthers.
topography or
Real-
hypsometry.
Real flat. Right. Real flat
height
earthers
height
are not
above
cubes.
sea level.
Real flat earthers don't try.
That's
real flat
two-dimensional,
earthers-
isn't it? A horizontal plane is a two-dimensional surface.
Real flat earthers don't think.
Is
that
that what you
hills and
imagine
valleys-
your surface of a sphere to be, like a horizontal
So
plane?
I need you to stop.
Is it that
interrupting
two
me.
dimensions? Because that's what I think 2 dimensions is. Like a horizontal plane. Right?
So, right. So you
Is
have
a horizontal
lost-
plane 2-dimensional, Brenda? Do you?
all planes are two-dimensional,
All right. Okay.
and the surface of a sphere is two-dimensional.
Hmm.
The surface of a cone is two-dimensional. The surface of a ellipsoid is two-dimensional, right? The surface of a hyperbolic saddle shape is
Like
two-dimensional.
the surface of a cube.
Two-dimensional.
So that is 2-dimensional, that though, isn't it? Did that throw a spanner in the works?
Yeah, it is a cube. The surface of a cube is two-dimensional, right?
Yeah, because they're individual
planar.
squares, aren't they? They're 2-dimensional shapes,
They're
right?
not- what do you mean individual? What do you mean individual? They're not individual.
The
face
surfaces, yes, of a cube, Brenda.
face.
Yes.
Right. It's flat, right?
Six,
and planar.
isn't there?
It's flat
6,
and planar. isn't
all
it?
square. Squares have
Right, it's
what? What's
two-dimensional.
the?
It's two-dimensional, correct?
When we say a square,
Because
yeah.
you can unfold.
Four right angles, 4 similar sides. Can you think of
Bev.
any more?
Bev.
The diagonals,
Bev.
both of the diagonals are the same length,
you just-
and they
Bev,
intersect
I need you to
perpendicularly.
focus.
Ooh,
Bev,
actually,
try
the
to focus.
sides of a
I'm talking
square
to you,
also
Bev.
have parallel.
Bev, I'm talking to you. I'm talking to you. Please respond. So if you take a cube, you can unfold it, and it can be a two-dimensional plane, right?
Yeah.
Right. So the surface of a cube is two-dimensional.
It's loads of squares. Yeah, I can see that.
Yeah. It's
Yeah.
so The
It doesn't
surface
roll.
of a cube,
When you put it on a two-dimensional surface, it goes flap, 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 because the
so
two-dimensional
you
surfaces
agree.
meet.
So
It,
you
it doesn't
agree.
roll because they're
Bev,
two-dimensional
I'm
surfaces.
talking. When I'm talking, I want you to listen to me, please.
Why is that? Do you think you've got something
Well,
that's
'cause
worthwhile
that's what,
for people to
what
hear?
adults well, that's what a conversation consists of,
Okay.
right? So I would like you to listen to me. So the surface of a cube is two-dimensional, and you agree to that, right?
Yes, it's squares. They're
Right,
two-dimensional shapes.
right. And the
Yes.
surface of a sphere is also two-dimensional
No,
because you
it's
can
three-dimensional.
unfold the
It
surface.
rolls.
No, you can unfold it. You can unfold it into a flat surface.
You can unfold a sphere into a
Yes,
flat
you
circle,
can
and you
unfold
can.
the surface of a sphere.
Can you? And
Not
can you put a
you
coordinate
just
system
just
on
like
that?
yes, you can.
A
That would be a
two-dimensional
polar.
coordinate system
That
on
would
it
be a
fits fine.
polar. That would be a polar coordinate system. You could do that. Yes, you can. Right? So you agree that a square is two-dimensional because you can unfold the square into a flat plane, and the surface of a sphere is also two-dimensional because you can unfold the surface of a sphere onto a two-dimensional plane.
No, I think it's three-dimensional. But I mean, if you
Oh,
think that's
okay.
possible, then
Well, then
good luck
what's the
to you.
third dimension? When I unfold or project the surface of a sphere onto a two-dimensional plane, tell me the third dimension.
But I don't know how you do that. How you project a
Yeah.
surface of a.
You're
It seems.
you're the person. You're the one that claims to be this geometry guy, and you don't know how to project the surface of a sphere onto a two-dimensional plane.
No,
You don't know this, and
I,
you're the
I
one claiming to
understand.
be the.
I
You're the one
understand how
claiming.
maps work and hypsometry works, right? Topography. I
No,
understand that.
that's
What
what
I
a map
don't
is. It's a
understand is
projection.
how
It's
you
a
can
projection
have
to
the
the plane.
surface of liquid water being a horizontal plane and imagine that bends around a ball.
Don't imagine. You project it. You don't know what a projection is?
I'm not very good at projecting, obviously.
Very good
You
at
seem much better
geometry.
at it than me, Brenda.
You don't know geometry at all if you don't understand this.
A projection.
Projections
To
onto the plane.
point us to where it says it.
This is a
I'm just
fundamental
dealing with
operation of maps.
basic Euclidean geometry.
Yeah,
Me.
that's all you know.
Yep.
That's all you know, right?
Yep.
And you don't even understand that.
Whoa. Well, I mean it's a
Well,
personal thing, isn't it?
earlier in the conversation, you demonstrated that you don't understand it.
Earlier in the
Euclidean
conversation,
geometry.
you said that me teaching geometry to my son was child abuse.
Yes, it is. I agree with Craig, Fight the Flat Earth, that yes, it's not illegal, right? It's not actionable, but it is a kind of abuse or neglect. Yes.
Really? Geometry, Euclidean geometry.
Yeah. Well, you're not teaching them geometry. That's the problem.
Pardon?
You don't understand geometry. You don't understand it. I showed that you don't understand it, like, what was it, 15, 20 minutes, half an hour ago. You don't understand even Euclidean geometry. You don't understand it. I showed that just half an hour ago. I showed that you have no idea of what you're fucking talking about at all, about anything.
I think this is the end of your journey now, Brenda. You've started resorting to insults.
Go on, give us a quick look on which is the most abusive part about Euclidean geometry.